Joshi ma'am, good afternoon.
Hello. Good afternoon, ma'am. Kalyani madam. Dr. Swati Bisikar here. Shraddha, am I audible?
Yes, ma'am, you're audible, ma'am.
Okay. Madam has joined.
Yes, ma'am.
Let's see that whether she can share the screen.
Good afternoon, Joshi, ma'am.
Click करा त्याच्यावर. हां. Start video. Yes. Screen share करायचं. Share. Then. आता तर PPT. Mute आहे. नाही आलं. Yes. Hello.
Hello, ma'am. Good afternoon, ma'am.
Good afternoon.
Bisikar, ma'am, can we start?
काय दिसतंय फक्त एवढंच. मी स्क्रीनवर दिसत.
Ma'am, with your permission, can we start?
Hello.
Hello, ma'am.
Yes.
Ma'am, with your permission, shall we begin?
Yes, no problem.
Good afternoon, all.
Good afternoon.
I welcome all for session 3 for the day. I take this privilege to welcome today's speaker, Dr. Mrs. Kalyani Joshi, ma'am, Principal Professor and Head of Electronics and Telecommunication Engineering Department, PES Modern College of Engineering, Pune. Ma'am has a PhD in adaptive techniques for quality improvement in image compression. Her research areas are digital signal and image processing, wireless communication, artificial intelligence in agriculture. Ma'am has 30 plus years of teaching experience. She has received various awards to her honor. To list a few: Best Teacher Award by Progressive Education Society in
Yes.
2019, Best Innovative Teacher Award by Savitribai Phule Pune University Quality Improvement Program in 2019, Outstanding Principal Award by Rotary Club of Pune Kothur, and Best Women Principal Award by Indian Society for Technical Education in 2008. She has published book Image and Video Compression Fundamentals, Techniques and Applications, CRC Press in 2015. Also book chapters like Quantitative Analysis of Radio Frequency Spectrum Occupancy for Cognitive Radio Network Deployment, Design of Microstrip Line BPF and Preamplifier for Adaptive Antenna System in book title Computing in Engineering and Technology, GPU-based denoising filter for knee MRI in book title Computational Vision and Biometrics, MRI denoising for healthcare in book title Biomedical Signal and Image. He has published number of papers in international journal and conferences. Ma'am has supervised over 20 projects students in masters and 45 undergraduate students. She has also worked as an ex-member of Board of Studies for Electronics and ENTC Engineering faculty at SPTU, member Academic Council at Cummins College of Engineering, Pune, worked as co-chairperson of WIE Pune section, worked as IEEE Student Branch Counselor, PES MCOE. Ma'am has also been appointed as a member of Board of Life Members of Progressive Education Society, Pune, appointed as a member of Management Committee of Bharatiya Vidya Bhavan, Sulochana Natu Vidya Mandir, Pune. She is also an active member of various organizations like MISTE, FIETE, senior member of IEEE, member of WIE, IEEE Education Society, IEEE Branch Counselor. Ma'am, on behalf of JSPM's Rajarshi Shahu College of Engineering and Department of EMPC, I, Shraddha Vingardive, welcome you, ma'am. And I request you to please start with the session.
Thank you, Shraddha. Good afternoon, one and all. Dr. Shailaja, Head of the Department of the Electronics and Telecommunication Engineering, and the whole team of the department, I congratulate you for arranging such a workshop under the AICT. Today, I am dealing with the e-healthcare. Madam, is it audible?
Yes, ma'am, you're audible, ma'am. Yeah. Hello, ma'am.
Systems, and these systems include learning, reasoning, and self-correction. So if you'll see the any system analysis or designing, these are the basic steps for the analysis, that is the learning, then reasoning, that is finding the cause and considering the specific impulse function, and correction through the feedback. So these are very common steps in any system design or the analysis. But the difference is we consider and further it was claimed as machine learning algorithm. Turing was one of the mathematicians who used the various computer algorithms for finding the location. Advanced machine learning algorithms termed as deep learning. Deep learning has allowed algorithms in the artificial intelligence to function with computational complexity and human-like intelligence that unlocks greatest potential. Many more researchers and scientists from biology, computer science, mathematics are working in this field. And while considering the research, artificial intelligence is categorized into four types. The first type is reactive machines, means where the healthcare comes, under which automated system with the deep learning and AI can be designed. Then the second type is the limited memory, for which past experiences are used.
Hello. Hello, madam.
Feelings of the human being through the machine learning. For this also, many more possibilities or problem statements are there. Applications of the artificial intelligence.
Hello. Hello, madam.
The various sectors which can be defined, which can be considered. Screen sharing is there. Okay. Is visible for all, no? Okay. So some of the applications I would like to mention over here in transport, data
Hello. Hello, madam. Your voice is not coming.
conditions. As well in education, we are aware of that. Many robots are teaching nowadays and not necessary to explain the other applications because all of we are aware of this field. As well, e-commerce, entertainment, animation related algorithms in the robotics, also many other applications can be used. Then upcoming area is the related things for the marketing and other sectors can utilize the data in much better manner. Then data security is one of the field for the AI where theft of data is the severe problem, and from so data security is important. As well, security
Hello. Hello. Madam. Hello, Joshi, madam.
huh?
Your voice is not coming.
Okay.
In break in between. Okay.
Hello.
Continuously. Voice is continuously break.
Is it audible now?
Now I audible. No problem.
Okay. Even in the astronomy, for example, at NASA, artificial astrology
Currently, voice is break. Madam. Hello. Joshi, madam. Your voice is break.
होगा Hello. Yes. Hello.
Hello. Hi, madam.
Hi, it's audible now.
Now audible. No problem.
Okay. Okay.
Hello. Madam, voice is not coming.
To emulate human cognition with analysis, interpretation, and comprehension of complicated algorithms in medical and healthcare data. So these machine learning algorithms are used for fast diagnosis. AI in healthcare to emulate human intelligence into computer technology that could assist both, that is for the end users, doctors as well as patients. Healthcare with artificial intelligence technology is the ability to gather data, process it, and give a well-defined output, that is the desired outcome, to the end user. Artificial intelligence does this process through machine learning algorithms and deep learning algorithms.
Hello. Hello, madam. Voice is not coming. Hello. Joshi, madam. Madam, you switch off your video.
Okay,
And then talk. Actually, maybe bandwidth problem.
is it okay?
Yes. Okay.
Okay, okay, thanks. So artificial intelligence programs are applied to practices such as, means where it can be used for the diagnosis process, where the biomedical imaging is the important technique. Then second type is the drug development for the creation of drugs, as well personalized medicine, patient monitoring and care, and even in telemedicine, as well in the electronic health records. Artificial intelligence is used to reduce overall cost and better accurate diagnosis with higher speed. We know that many companies are working in this. For example, IBM with Watson Oncology project, Microsoft for Hanover project, Google's DeepMind, and NVIDIA for gaming technologies with the healthcare is coming ahead. So there is huge scope to work in this area with the various algorithms.
Okay, madam. Your voice is not coming.
Hello,
Yes, madam.
sir, is it audible or shall I connect from my phone?
Yes, you connect with your phone.
Okay, okay. आपल्याला इथे एकेकाळी हे असं सायमल्टेनियस दिसते. स्वाती बिस्सीकरचाच फोन. म्यूट म्यूट म्यूट
Hello, madam. You actually unmute your mic.
Hello, Vagas sir.
Hello, madam.
Sir, actually, I have connected.
Hello? Hello?
Hi, yes, madam.
Okay.
Your voice audible. Yes.
Okay. Okay.
Hello, madam. Again, your voice is not coming. Please check.
Sir, is it audible?
Yes, audible, audible.
Okay. 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 So some of the components or the tools which can be used with the specific standard algorithms are machine learning, NLP, that is the natural language processing, expert systems, neural network, computer vision, and robotics. Machine learning is the predictive analysis. Its ability to automatically learn and improve from experience without being explicitly programmed. So, for example, is the Netflix where the movies or your series
Hello, madam. Joshi, madam.
Vagas sir,
Yes, madam.
I will tell her. Once
Okay,
again,
you
I have
call now.
already discussed.
Okay.
I think Madam has joined. Hello, Madam. Hello, Vagas sir.
Yes, madam.
Madam will continue with, after 2 minutes. Just after two
Yes,
minutes, he is
yes, yes.
trying. Okay.
Okay.
Unmute. Hello. Hello. Hello, madam.
Hello, hi. Hello, madam.
Swati.
Audible.
Ha. Okay.
Audible.
Yes, madam,
Actually,
you
the
are.
internet connection is on. Okay. So in the expert system, I will explain again all the computer applications to solve the various problems in the medical domain, and we will see some of the case studies to develop the expert systems that can conduct medical operations on the human. Monitoring systems which compare data continuously and tell the behavior of the system. For example, leakage monitoring in long petroleum pipeline. So in neural network, training processes are the important part, and many other applications are there with the neural network. The main focus is on the computer vision. Computer vision is a technique that implements deep learning and pattern identification to interpret the content of an image, including the graphs, tables, pictures within PDF documents, as well text and video. Computer vision is an integral field of artificial intelligence, enabling computers to identify, process, and interpret the visual data. Computer vision is being used to diagnose patients faster by using computer vision and machine learning to evaluate patients' X-ray or CT scan images, PET images. So we'll see some of the case studies with the computer-aided design in the further slides. Robotics is one of the domain where robots are used for the operations without disturbing the human body. So these are some of the components which can be used with the AI for the various applications, and these components are nothing but the tools can be used with the specific platforms for to cater the particular application. Design, how to design the artificial intelligence system. You might be thinking of that, why I'm explaining all the design tools or the algorithms in the AI. But the main aim of explaining all this is nothing but the designing of the system is the common process for all the applications. The application may be any field, but the designing, tool selection, and the algorithm implementation, the common algorithms are used in the artificial intelligence. And just to explain about that, I will go through these 2-3 slides related to design and algorithms in artificial intelligence. So how the system, AI system can be designed. So always we should know the problem statement, that is nothing but the identification of the problem for the desired outcome, and depending on the desired output data, the input data signal should be identified. Then the next step is the pre-processing or the preparation of the data. For all systems, pre-processing is utmost important step. So pre-processing or the preparation is nothing but the input signal, that is the given data, then cleaning or preparation and manipulation of the data. For example, for computer vision, we can consider denoising algorithms for cleaning the given image, and that is very much important because this signal is directly given to the artificial intelligence system, and some of the standard algorithms in the AI are classification and segmentation. So that time, if signal is not clean, if signal is not pre-processed, then the degradation gets multiplied. And that's why pre-processing is the very important step in any designing system. And it is also considered in the AI system for any kind of the application. Then next step is the selection of the algorithm for training the particular data or training the algorithm. So supervised and unsupervised training algorithms are used. Then testing that output data and the validation is the important task for said purpose. After completion of this classification, segmentation, regression, then very important thing is to select or to choose the particular programming language for particular platform. So selection, high level programming libraries are easily available nowadays on the internet. So smart selection of available programs for available platform is the important technique for particular application. And so it will simplify our system designing. So huge tools are available for the programming also. So after designing, we have to consider the which algorithm can be implemented for the specific application. So these are the very common steps which are used in the artificial intelligence. So always first ask the question whether the data is to be selected in which manner. So for example, the first point is if the data is to be selected A or B, then the particular algorithm of the AI is the classification algorithm should be selected. So under the classification algorithm, naive Bayes, decision tree, logistic regression, or support vector machine, KNN, CNN are the common algorithms in the AI. Then second question, there is data which is different than this. Then we have to select the anomaly detection algorithm. And for that, standard algorithms are PCA, GMM, K-means, SVD, and many other. If the question is how much or how many signal or quantity data has to be selected, then obviously we have to consider regression algorithm. So linear regression analysis algorithms are available, which are standard algorithms for this technique. Then how the data is organized, from this question we can select the algorithm, clustering algorithm, with K-means or the GMM techniques. After selection of the algorithm, problem can be solved depending on the type of the problems which are considered. So here, mathematics plays important role in all these steps. Machine learning is subfield of artificial intelligence. Machine learning uses supervised, unsupervised learning, reinforcement learning, or ensemble learning. To use any of this algorithm, identified problem can be categorized as regression. For example, for prediction of the forecast or for the stock market prices, can be used. Second algorithm is the classification algorithm. For example, emails can be classified as a spam mails or non-spam mails. The next, clustering algorithms for grouping of certain quantities, certain data. For example, all transactions of the fraud can be collected together and can be grouped together. The next step is the dimensional selection. So example is to redundancy of the feature can be applicable directly. So by using types of the problems, we have to select the particular algorithms with the machine learning. So the given problem can be solved with the machine learning techniques for specific application. So it is not possible to explain each and every point and is expected for today's session also. Just to mention few, the machine learning, all these algorithms are standard algorithms and we are applied as per the system defined. For example, recommender system, then we have to select the particular algorithm. If it is a learning task, then machine learning task is a type of prediction of inference being made and based on the problem or question that is being asked and the available data. So for example, the classification of the task assigns data to categories and clustering task groups data according to the similarity. So for the biomedical imaging, big data visualization is also the important point, and it can be considered data visualization uses algorithms to create images from the data so human can understand and respond to that data effectively. So artificial intelligence development is the quest for algorithms that can understand and respond to the particular data. The same was human who can do in better way. So we know all these algorithms and how to be implemented for a particular application. So till this slide, till this point, we have seen artificial intelligence applications in all fields. And especially I have mentioned some of the applications in the healthcare, bioimaging, biological sciences. We know that the many giant companies, universities, medical practitioners, and researchers are working in this area. But we know that in this era, we are dealing with artificial intelligence. But in our ancient Vedas, there is a root of all these artificial intelligence mathematics, that is the Vedic maths, predictions, wave theory, atom theory. Even we know that number of missiles, for example, which are related to the Panchamahabhuta, Agni missile, Parjanya missile, even the Sanskrit was the common language for the natural language processing. So what I want to tell you that all these concepts are very old. And so artificial intelligence is very much known and it was in practice in India. And because of data preserve, and we know that the whole database and database management is also the important task for the artificial intelligence. And in mythology, the data was preserved through granthas, Vedas, Puranas in a strategic manner. And algorithms are explained through mythological experiences, stories, mantras, Vedic with the Sanskrit, with our various rituals. That means for every event, there was a logic and science behind it. I can narrate one common example. Sanjay was explaining the story of the battle which was going on in the Mahabharata. He was explaining it to Dhritarashtra. So Sanjay is the best example of computer vision, deep learning, as well machine learning, because he was explaining the Akho Dekha Hal and getting the feedback from the Dhritarashtra, and he was conveying the correct decision to Kauravas. So we know many more stories in mythology which are nothing but the roots of the AI. But in today's era, we have to consider AI in the different wrapper with the applications which are available at the fingertip. And so AI is very important in the healthcare to automate the systems for diagnosis, even for the surgeries. So here are the some of the systems which can be used for the healthcare. That is the expert system with the computer vision. This is an expert system, which is a computer system that emulates decision making ability of the human expert. Here you can see the communication between the non-expert user and the expert user, so that it's quite easier because of the communication technology to get the decision from the experts to the end user. So expert system will generate the advice for non-expert user, making use of knowledge from the experts. Here I can mention some of the examples which are available for the computer-aided systems. That is mycin, which is used for MYCIN, which is used for bacterial disease detection. As well, one more system is available, that is CADET, CADET, which is used for the cancer detections. And similar to these systems, in our research group, we have implemented CAD system for diagnosis, for biomedical imaging, for cancer detection, Alzheimer disease, that we will see in the first slides. Applications of the AI in medical image diagnosis and analysis. So CAD is a computer-aided diagnosis. It is an emerging field with the goal of providing computer assistance to the radiologists and at the time of diagnostic decision making. That is very important. AI algorithms have key role to play the development of such CAD systems. Some of our case studies include development of CAD systems based on brain MRI scans. Brain magnetic resonance imaging is an important non-invasive method for visualizing the human brain and for examining the brain's anatomical structure. If a suspicious region is detected on the MRI by radiologists, he or she must then visually assess various radiographic characteristics. Here we have considered the three case studies in my presentation, and I am happy to share with you all these case studies we have implemented with my PhD students, ME students, and undergraduate students. So first case study we have considered, that is the MRI pre-processing. In this pre-processing, we have considered denoising and contrast enhancement, that is a restoration and contrast enhancement techniques. In second case, development of CAD for tumor detection and classification. In third case, the whole CAD system for Alzheimer disease detection and classification we have considered. So we have developed the CAD system. Each development of this CAD system include these steps. The steps are mentioned here. Selection of the MRI scan. It can be seen MRI scans can be axial. On the right side of the screen are shown axial, coaxial or sagittal. Selection of MRI images which can be T1, T2 or PD weighted. MRI pre-processing which consists of denoising and contrast enhancement. So preparation of training database is the important step that we have considered. Then feature extraction and selection of the optimal features is the next important step. We have used the classifiers KNN, SVM and AdaBoost AdaBoost, improvisation in the AdaBoost and some of the adaptive techniques in that classifier is our contribution. Performance evaluation using different quality metrics is considered for the assessment of quality in this case. And the validation is the very important step for which we have taken the feedback from the experts, that is from 3 radiologists, and the typical classes considered for the brain tumor classification, such as on the lowest row, it's given as benign tumor, malignancy or the high grade, low grade glioma, and also the disease progression stages from normal, that is NC. On the right hand side, it's given normal to Alzheimer disease, that is the AD, development of the tissues are shown, and its intermediate stage called as the multiple cognitive impairment, MCI. So we could achieve the highest analysis with this. One more CAD system which was developed, which include the steps. There are the 2 steps, MRI pre-processing and the tumor detection and the Alzheimer disease detection. So everywhere you must have seen that the very important step, the pre-processing is considered. So always we have to remember that for any kind of the biomedical signal, the pre-processing is the important step. Why so? If you are considering the ultrasound image, then ultrasound transducer is the resource, and from the transducer it's conveyed given to the sensor. So number of sensors are used for all types of the medical signals. When we are using the sensor signals from such type of transducers in the medical imaging, always the degradation is the multiplicative type, and so that the degradation increases as the number of input signals are coming from that transducer. And if you'll give the direct signal to the classifier or to any kind of the AI algorithm, then that noise will get added more with multiplicative rate. And that's why pre-processing in the medical imaging, whether it is a ECG signal, if it is a one-dimensional signal or two-dimensional image, everywhere the pre-processing is the important task. And in the slide, we have shown the hardware acceleration with the CUDA and FPGA. So with the other 2 case studies, we have implemented HWA, that is the hardware accelerators, with the CUDA for denoising of MRI, and with FPGA with the parallel computing approach that I will show later. So what I want to summarize: pre-processing, feature extraction, then appropriate selection of the algorithm, training algorithm, classifier, then performance evaluation, which is based on the quality metrics for the assessment of the quality, and the validation with the expert opinion. These are basic steps which can be used for the biomedical imaging with the artificial intelligence technique. Already we have seen all these basic steps for the AI, and that's why I have repeated all these steps again. Then one of the case study, that is a CAD system, computer aided design system for the brain tumor detection and classification is mentioned here. In this case, 2 approaches have been applied. One is cascade approach and the other is the single step multi-class classification. In cascade approach, the given brain MRI, brain image has been classified as a normal, abnormal, that is level 1. So mention as a normal or abnormal. In level 2, we have considered benign or malignance. Then in level 3, malignant scan has been further classified as glioma or meningioma. That is in the level 3. In level 4, high grade glioma or low grade glioma is considered for the classification. So in single step multiple class approach, in a single execution cycle, scan will be labeled as normal, benign, glioma, meningioma, and this can be classified for the patient diagnosis purpose. Sample database typically used for this CAD system for development of this CAD includes MRI scans from readily available data sets on internet, pre-labeled scan collected from various hospitals in India and especially in Pune also. I have mentioned those hospitals, Sahyadri, Dinanath, KEM and Ruby Clinic. So we could achieve and we could classify the actual brain tumor and it was detected properly, and on this many publications are available in the international journal also, and this was contributed along with by Mrs. Kamthe for this project. In the next slide we have shown the results are summarized and obtained from developed CAD system for brain tumor classification and detection. As it can be seen, results are indicated in terms of classification. Accuracy for different feature sets are also included. Appropriate feature selection and optimization of the feature sets is one of the important steps towards achieving higher classification accuracy. Also, validation of such systems from the end user, that means from the experts, for example, from the radiologist, is must. So feedback can be taken in different formats. Here, one of the sample is shown, which is a feedback from radiologist, which is included in this slide. One more case study for the Alzheimer disease detection and classification. For another case study included in this presentation, that means development of the CAD system for Alzheimer's disease detection and classification. In this case study, we have used typical database available such as OASIS and ADNI, that is Alzheimer's Disease Neuroimaging Initiative. The sites are given here. Algorithms include SVM, KNN, and AdaBoost. In this work, features were optimized using forward selection and backward elimination method. CAD system here includes 4 models in which classification is carried out as abnormal versus normal, then Alzheimer's disease versus multiple cognitive impairment, and so on is given in this table. Sample results of the implemented CAD system for Alzheimer's disease are shown over here. Receiver operating characteristic, that is ROC, depicts promising results for the AdaBoost classifier. In the previous slide, I had mentioned the AdaBoost is our contribution, which is compared with the standard KNN, and we could achieve the highest results for this and were recognized by the various journals also. Till this point, I have explained you some of the case studies with the computer-aided design for the Alzheimer and for classification of the cancer patients, as well for the size of the tumor and other related projects can be implemented. Still, there is a huge chance to work in this area. Now, the next case study, the remaining 2 case studies are related to the pre-processing of MRI. Already I had mentioned why pre-processing is important in medical imaging. So preparation of data, that is the pre-processing for the computer-based biomedical imaging, is very important when noise is signal dependent. In case of MR images which are contaminated with a Rician noise is one of the noise model which is multiplicative in nature and making it very difficult to remove from the given signal. And it is a very difficult task in the medical images because organs or the diagnosis related to the organs is related to age detection and total size of that organ. So all the fine details are present in the high frequency, and at the same time this multiplicative nature noise signal is also present in the high frequency. So it is very difficult to sort out the noise from the fine details, because fine details are also important because for the organ detection, the age preservation with noise removal is the important task, and which is too tedious, but we have to achieve that. Otherwise, the noise will get multiplied in the classification or the segmentation algorithms. So in CAD system, classifier system plays a major role in automatic detection and diagnosis. If wrong input, that means noisy signal, is applied to classifier, then incorrect classification takes place, leading to incorrect output. That means removal of noise from the MR image is very essential. So we have used nonlinear filters as well as linear filters, and mostly NLM bilateral filters are used for this purpose. This motivates to implement the filter when we have considered number of filters for the denoising techniques. Then we could find out the problem associated with all these filters is that the computational complexity is very high for all denoising filters. And while considering the computational complexity, memory and the speed is utmost important for the CAD systems for the faster diagnosis. And medical images are with the higher storage. So this motivated us to implement the filters on the parallel platform. And so for the parallel computation approach, we had selected the two different platforms. The first one is with the CUDA and the second is with FPGA. And especially these two platforms we have selected to reduce the time of the complexity calculation and less usage of the memory. Under this is the first case study for the denoising of the MRI. You can see the overall system which we had implemented. Out of that, improved image quality was possible because of the image denoising. And for that purpose, instead of CPU, we have used the hardware accelerator with CUDA. And in this project, the main aim was to pre-process the given image for quality enhanced CAD output. So removal of the noise with various restoration filters is considered for telemedicine, for as well as to get the expert's opinion. These images communicated from rural area to experts in the urban area. So huge data with high memory usage with good quality of the image was the main concern of this project. And we have developed all this and overcome these concerns with the adaptive pre-processing algorithms with bilateral filters on the platform of CUDA with parallel computation, with which we could achieve high speed, less time, less memory usage. The case study is in the domain of MR diagnostics, highlighting use of GPU devices for real-time denoising process for MR image. We have considered brain and knee disorders, which are observed mainly in old age patients who may not be mobile enough. So telediagnostics and treatment is significant for healthcare of such immobile patients deprived of medical facilities. MRI being a diagnostic technique, its quality plays a key role in accuracy of diagnosis. So Rician noise with the relay model. Rician noise is the,
प्रोडक्ट आहेत
while
का
considering the noise.
काय नमस्कार. तुमच्या दोघांपैकी दोघे ओळखत बरं का मला जो दोघं ओळखू येत नाही.
Hello. So, which is very important and difficult to nullify to reduce the Rician noise, because Rician noise is the combination of the additive and multiplicative. And that's it is a senseless multiplicative noise. At first, it is with the relay model, but after some time, it gets converted into the additive noise. So selection of the filter was the very important step for the denoising techniques of the MRI. And we have developed 4 filters on the GPU, and we have taken the advice from the NVIDIA people along with the experts radiologists, and it was considerably improvised version from the both experts opinion. Then second case study we have considered for the denoising. Instead of CUDA, now we have used the platform was the FPGA. So the main purpose, the whole pre-processing system is developed on the FPGA platform instead of CUDA. FPGA gives the faster outcome with which we could achieve the highest speed. The remaining pre-processing techniques, the FPGA, that is the hardware accelerator with FPGA. For that, we have modified and designed the adaptive filter SNLM, that is a soft NLM filter. And because of that, this work achieves 0.99 SSIM metric, that is the structural similarity metric, 98% of age matching with the original image, and there is an approximate 3% improvement in SSIM and other quality metrics which are compared with the original NLM filter. While considering the speed or time, the filter execution time observed was 0.0577 second, making its real time. So compared to CUDA, it was the hardware accelerator in the real-time application. It can be used directly. And we got the good results for the real-time application. The research shows that parallel implementation of this adaptive SNLM achieves 700 times speed up than sequential implementation, which was the highest achievement for this FPGA platform. FPGA performance is measured by different parameters such as lookup table, LUT, DSP block. So LUT flip-flop utilizes 50%, DSP blocks utilize 6%, indicating minimum hardware utilization. Why am I saying again and again? Because out of the whichever available hardware accelerator with the FPGA, we could achieve these results with the minimum hardware which was considered in the FPGA. This research work significantly improved telemedicine by contributing performance tuning of SNLM filter in terms of execution time. So there is an opportunity to improve this performance further by selecting FPGA devices with higher computing ability. So in next slide, we can check the performances based on the quality measures. Here I have mentioned the filters, that is the hardware accelerator SNLM filter. The time utilized is 0.058, and for the SNLM filter on MATLAB it was 41. So beauty of this project, I would like to say that, see, when we are considering all these algorithms, especially for the biomedical imaging, what we are considering, all these can be used only for the biomedical applications. But it is not the case. Already we have implemented this algorithm and got the good results for driverless car algorithms. So how it can be used? When we have considered the MRI denoising, there was a main purpose of removal of added noise. And when we are considering the driverless car, that time blurred images are considered. So enhancement or the restoration of the blurred images with the real-time processing is very tedious task, and that we could achieve with this algorithm. So why I'm mentioning this again, for the researchers, you can think about all these hardware accelerators or the real-time processors which can be implemented, which can be used for the various other applications also. In my research, when I was working on the synthetic aperture radar images, that time for the various compression techniques, especially for the set partitioning hierarchical technique, SPIHT, which was comparable to JPEG and JPEG 2000 compression. You might be knowing for the DICOM X-ray machines, SPIHT compression is used. Why I'm mentioning this? Because of the quality measures, because of the noise type present in the SAR images and ultrasound images. Both are in multiplicative nature, and depending on that degradation, I use all the synthetic aperture radar imaging filters. You must be knowing the Lee, Kuan, and overall 12 filters are available for the synthetic aperture radar imaging. So directly I had implemented all these filters for the ultrasound images, and I got the very good results for the compression technique SPIHT with good quality. So my concern is that when you are studying the artificial intelligence, deep learning, image processing, computer vision, it may be for biomedical imaging, it may be for agricultural or for any kind of other application in NASA, somewhere else. Every time we should be very alert and we should know the what kind of input signal is. Always all these algorithms are based on your input data signal and what is your desired outcome signal, and accordingly we'll have to process the given input signal. So you can utilize all these algorithms for other applications also, not only for the medical imaging. So till this point, I have explained 5 to 6 case studies which we did in our research group. Along with me, Mrs. Kamthe, Mrs. Bode, Mrs. Hansate, Ms. Shraddha Oza, and other PG and UG students have worked. And henceforth, I will explain some of the health applications which are available, and there is a room to work in this area also. If you see this diagram, this is a health app. Here, the data processing with the communication, that's here embedded systems, IoT, cloud computing, communication, microcontroller, processing, as well data processing. All these types are used for the processing purpose for the specific health application. So this can be used. You must have seen the number of fitness trackers which are available in the market with the reasonable price. So we can select any one of that signal. You must be knowing Fitbit, Garmin, Everlast, Sumo, and we can name many more. So smart watches like this from Apple, Samsung, this capability are used. But these fitness trackers can be modified, like research, like wearable and monitored, can be monitored as an overall healthcare system. So your heart rate, oxygen saturation level, body and skin temperature, blood pressure, and uses it for other physical characteristics to help you monitor your physical activity. So with this information, the tracker can predict or determine what your body is doing. Trackers are wearables that implement what has come to be known as preventive healthcare. So next example here shown is the wearable fitness band. In this case, we have considered number of parameters from the various sensors. So you can add number of sensors to complete the whole health monitoring system. In this case, the PPG signal is considered for various oxygen levels, that is the photoplethysmography, that is PPGs, with pulse oximeter, with sensors for optical pulse oximeter, which counts heartbeats. Heart rate is widely used to determine not only physical activity, but stress level, sleep effectiveness. So along with this health monitoring, we can implement accelerometer, barometer, gyroscope, magnetometer, biopotential, bioimpedance measurement, temperature measurement, or you can give one sensor signal to one UG project, and accordingly you can create a whole healthcare system with all these types of the sensor signals. I'm happy to share you that two UG projects are working on this, on the two sensors in our college at the Department of Electronics and Technology Department, Engineering. One of the projects is the AI-based wireless digital stethoscope. At the end of the session, I will play one video, the e-stethoscope, which is available for health. Out of that, we have selected the heartbeat for the chest piece, from the chest piece, and only that signal is processed, and our students are working on this project, the one step towards the modern telemedicine approach. In this case, we can consider heart sound, ECG, and decoded signal can process the artificial intelligence algorithms. So whichever the CAD system we have seen, it is indirectly the picture of the CAD system is in this way. The interpreting medical imaging, it may be X-rays, CTs, MRIs, ultrasound images, scans, is highly skilled manual job requiring many years of training. So radiologists are important. So demand for imaging outstrips supply of qualified radiologists, and this trend is likely to continue with an aging population and growing access to technological healthcare solutions. So this type of CAD systems will be available in the market soon. And for such type of system, we have implemented 4 to 5 algorithms in our department. With this, I conclude my session with the various topics which I have covered in the biomedical imaging, as well computer vision, the deep learning, and especially 4 to 5 CAD systems I have explained, which we had implemented And the two pre-processing systems are also explained with the various platforms of CUDA, FPGA. So with related to these, all these applications, even we have seen the variable Fitbit and other techniques. So there is a huge scope to develop all these sensor signals with IoT and with the embedded system, as well with the computer vision with AI algorithms. So some of the applications or the problem statements on which you can work. So some of the problem statements which will lead from these points: the automatic classification system for the MRI scans, then proposed framework for the Alzheimer disease can be implemented for CAD systems for other types of the brain lesions. Anatomical changes depicted in the MRIs due to different disease symptoms. For example, we have mentioned the tumor and multiple sclerosis can be studied further for development of the new textural features and can be combined with the results of different pathological findings tests. So experimentation with large data sets of Indian patients and validation from the end users can be done. Implementation of digital stethoscope by monitoring health parameters like ECG, EEG with the smart asset, smart monitoring system is also one of the area, one of the domain where we can work. Implementation of IoT, cloud, and big data analytics in the smart healthcare. That is the one more domain where there are the n number of research problems are available. Then arterial stiffness estimation using PPG signal analysis is also one of the problem statement. So I can add many more problem statements, but with the time limit, I have to conclude my session with one of the video. I would like to show you video of the e-stethoscope, which is available in market. They have considered the ultrasound imaging and other techniques, but we can work with the other signals also. With this, I am concluding my session. Thank you, madam. Thank you all the audience for the patient
Hello.
listening.
Thank you, madam.
Hello.
Hello, madam. May I audible?
Yes, sir. Yes.
Madam, one question is actually from audience. which algorithm is suitable for feature extraction, suppose for Alzheimer disease detection. Hello.
It's mentioned over there the CNN algorithms. KNN, CNN are the best algorithms for the Alzheimer diseases.
Okay.
Audible? Is it audible?
Yes, madam.
Yes.
Okay. And could you
Okay.
please suggest us scope for PhD related research?
That I have explained in the last slide. The PhD related research. Shall I come to that slide again?
Yes.
Please. Hello.
Yes, madam. Yes. Visible.
Yes, you can see all these problem statements which are related to our CAD systems. You can work further on those. Even in the many other areas are mentioned. Implementation of IoT, cloud and big data analytics in the smart healthcare system. For example, for the patient monitoring systems which are available right now in the hospitals are with very less sensors, with less number of sensors are included. But we can consider the smart healthcare system as a whole system. Even PPG signal classification analysis for the arterial detection, the stiffness detection and estimation is the important problem statement. Even for the MRI denoising, we have mentioned the 5 to 7 filters we have implemented on CUDA and FPGA. But still there is a huge scope for ultrasound imaging as well for CT scan imaging also. Even there is very less work is considered on the X-ray imaging. So you
Uh,
can go for X-ray imaging research, which will be useful for which e-stethoscope we have seen.
Madam,
Is it?
what is the advantage of FPGA device for? Uh,
Okay. Okay. That I have mentioned in the FPGA, parallel computation is possible. And with the various logic gates, you must be knowing the basics of the FPGA.
yes, madam.
So with that, we can define the specific algorithm. For example, if you want to implement the DSP filter, so directly that filter can be implemented on the FPGA chip and it can be considered for that particular mathematical operation separately. So the all the mathematical operations can be performed on the FPGA with the parallel data processing, which minimizes the time as well the increases the speed of the system. And so FPGAs can be used directly for the real time processing. And that's why I had given the example of the driverless car algorithm. That is the enhancement algorithm can be implemented for the blurred images directly on FPGA, which will give the real time results. And this is implemented in Tesla. You can check the Tesla site also.
Okay. Okay. Thank you, madam.
Yes.
Uh, Thank you very much, madam. Good afternoon, one and all. I, Dr. S.C. Vagas, on behalf of Rajarshi Shahu College of Engineering, Tathode, Pune, extend a very hearty vote of thanks to dynamic personality, Dr. Mrs. Kalyani Joshi, for sharing her valuable thoughts. Madam, thank you very much for exploring application areas of AI in healthcare, expert system with computer vision, results of CAD system for brain tumor and Alzheimer's disease detection and classification, implementation using CUDA platform, filter implementation using FPGA, and artificial intelligence related application problems. Uh, This session has given informative in this regard. Thank you very much, madam.
Thank you all.
Thank you.
Thank you, sir. Thank you.
Yes.
Yes, yes. Shall I leave? Yes.
Yes, madam.
Okay. Thank you, sir.
Yes.
Thank you, Shailaja madam.
Thank you, madam.
Thank you for inviting. Yes.
Yes. Budbule sir, or Basiker madam.